Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are working on the year-end summative. It's question 12, which is from the quadratic relations section. Let's look at that question. Given a quadratic equation, if the equation of the axis of symmetry of the graph of this function is at x equals 2, and an x-intercept is defined by the ordered pair -1, 0, then what are the coordinates of the other x-intercept? Show all your work. Okay, so let's summarize what we know. We know that the axis of symmetry, and this is how I short form it, the axis of symmetry is the line x equals 2. We have one root, or x-intercept, at -1, 0, and therefore the other root is the thing we need to find. So I don't know what it is. I do know the y-coordinate is 0 because a root is an x-intercept, and by definition x-intercepts have y equal to 0. So you may know the answer already, but it does say to show all your work. So the expectation is not that you just write the answer, but that you find some way of demonstrating how you know the answer. So for me, I'm going to draw a picture. This is the way I like to demonstrate, if I can, how I know something. So I pulled out the XY axis, and let me label X and Y. And I'm going to add the axis of symmetry to this graph. So at X equals 2, I have this red dotted line, and I guess it should go in both directions. So let me just fix that. Some things are easier with a ruler and a piece of paper because you don't have to, click, click, click. But it sure is neat. Okay, so there's my axis of symmetry, and I better label it so that my teacher knows that I know exactly what I'm doing. So this is X equals 2, and it's the axis of symmetry. And I also know that one of my roots is at the point -1, 0. So I'll put that on there, and I'll write the coordinates again, so my teacher knows exactly what I'm thinking. Now, here's what I know. I know that the axis of symmetry represents the middle line of your parabola. And each parabola effectively is a perfect mirror image of itself over the axis of symmetry. So every point has a horizontal partner that is exactly the same units away from the axis of symmetry, but in the other direction. So this point here is 1, 2, 3 units to the left. That's the root I know. Therefore, there is another root 3 units to the right of the axis of symmetry. So again, every point is mirrored on the other side of the axis of symmetry in a perfectly horizontal direction. So this was 3 units to the left. So my point will be 3 units to the right, which would make it the point 5, 0. So I don't know if your teacher needs you to do any more explanation than just what you've got on this diagram. You can certainly write kind of the things we were talking about. For example, that the axis of symmetry is a mirror that reflects each point onto the other side of the axis. That's kind of casual. That's why I was using quotations, because that certainly isn't any sort of mathematical language. I mean, that's more science language, right? To talk about mirror reflecting. Maybe I should say that since it's a C, since -1, 0 is 3 units to the left of the axis of symmetry, then the other root is 3 units to the right of the axis of symmetry. So therefore, 2 minus 3 equals -1, and that gave me -1, 0. So 2 plus 3 equals 5, and that gives me 5, 0. So I'm not sure what your teacher expects. I think that the graph, the way that we've written stuff on the graph like this, should be fairly clear. But just in case, you know, you can always write stuff like this. So that's certainly good enough for A. Let's look at B. B says to write the equation of this quadratic in this form, so that's factored form, given that the y-intercept of the graph is 10. So here's what factored form looks like. And I know it's typed above, but whatever. So here's factored form. And here's the information now. The y-intercept is 10. So here's the y-intercept. It's a point. I also have my 2 roots here. Now, having the roots is the best thing you can have if you want factored form, right? Because factored form gives you the roots, and therefore the roots can give you factored form. So how do we do it? Well, let's look carefully at our roots. I know that x equals -1 is a root. So rearranging, x plus 1 must equal 0, and therefore x plus 1 is a factor. And so this bracket here will be replaced with x plus 1 because that's a factor. Same thing with the other root. I know that x equals 5. So x minus 5 must equal 0. And so therefore x minus 5 is a factor. So let's put a new page up and rewrite my equation. Now I still don't know what a is. So I'm just going to have to write a. But I now know that my 2 factors are x plus 1 and x minus 5. But I don't know a yet. So the other piece of information that I know is I know that the y-intercept is right here. And if I know the y-intercept, what I know is an x value and a y value that satisfy this equation. So that means I can do a substitution. Let x equal 0, substitute, and at the same time let x equal 10, let y equal 10, and I'll be able to do algebra, and my only unknown will be a. So that's what we're going to do. We're going to do a substitution for x and for y, and that'll allow us to solve for a. Okay, so again, y was 10, x was 0, so there we go. Do the math. So 10 equals a times 1 times -5. So 10 equals a times -5. Divide both sides by -5, and you get a equals -2. So now I have everything I need. Here is the equation of that quadratic in fully factored form. Okay, there's my answer for B. Excellent. So let's look at C. C says, write the equation of this quadratic in vertex form and show your work. Okay, so again, this is the quadratic that we have, x plus 1 and x minus 5. And we want to write it in this form. So again, this is vertex form. Oops, we don't want that little bit there. Oh, what just happened? Sorry. There. Ooh, press some random button. Okay. So we have it in factored form and we want it in standard form. Sorry, we want it in vertex form. Now we don't know the vertex. So what could we do? Well, one option is to write this in standard form. So we can simply do algebra and rewrite factored form into standard form. Then from standard form, we could complete the square. Oops. We could complete the square, and that would give us vertex form. And that's a perfectly valid method, but think about all the algebra and math that would go into this method. There's actually a different thing we could do. Now, first of all, let's look at what we know. We know the value of a for this quadratic because a is the one thing that doesn't change between standard form, factored form, and vertex form. A is always, in this case, -2. What else do we know? Well, we know several points that we could use for x and y. So for example, if we think about the y-intercept, we could use 0 for x and 10 for y. So we know a, we know y, and we know x. Now, we also know, and just in case you forget, it's right here, we know that the axis of symmetry is at x equals 2. And that means that the vertex is at 2 comma something. because the vertex is always right on the axis of symmetry. So this value here is the h value of the vertex. Oh, so we know that. In fact, the only thing we don't know is k. So we can just do a substitution of all of these values, and then we can solve for k. So let's go ahead and do that on a nice clean paper. So y equals -2 x minus 2 squared plus k. And again, the point we were going to use was the y-intercept. So there we go. So -2 is a. I'm using the point 0, 10. And we knew that the axis of symmetry was at 2, so that must be the x-coordinate of my vertex. So now I just have to do this math, and I'll be able to solve for k. So here, 0 minus 2 is -2. -2 squared is +4. So -2 times 4 is -8. Add 8 to both sides, and I know the value of k. So therefore, I know the equation of this line, the equation of this quadratic is right here. So my vertex is at 2, 18, and the a value is -2. So we're all done the question, but since I had mentioned that there was this other method, let's do this method just so that we can say that we saw it, and maybe this was the method you tried and you want to see the full solution. So let's go ahead and do that. So again, I'm going to start with the full factored form, which looks like this. And then I'm going to do algebra and turn it into standard form. So that means I'm going to multiply everything together. So doing FOIL, x times x is x squared. X times -5 is -5x. 1 times x is +x. And 1 times -5 is -5. So collect like terms inside of that bracket. I get x squared minus 4x minus 5. And now I'm going to multiply everything by -2. So -2 x squared. -2 times -4x is +8x. And -2 times -5 is +10. So there it is in standard form. And now I'm going to complete the square. Okay, so to complete the square, whatever the coefficient is in front of x squared, you factor it. But you only factor it out of the first two terms. That third term, that constant, just, send it to the side. We'll worry about it later. So factoring -2 out gives me x squared, and +8 divided by -2. Okay, so that's -4x. So now, extend. Now I do the actual step called completing the square, which is where I put a number here to make a perfect square trinomial. So this is what your brain should be doing. Brain, oops, sorry, went off screen a little, if you didn't like it. Oh no, my brain is a mess. Okay, so I need to take -4. I need to take half of it. So half of -4 is -2, square that, and I get 4. So the number that I need to add and subtract is 4. So I'm going to add 4. And of course, if you add something, you have to subtract it, or else you're fundamentally changing the equation. So adding 4 and subtracting 4 is like adding 0. So adding 0 never hurt anybody. So that's what we did. So now the next step is, sorry I'm writing in red, but whatever. This -4, I don't want that inside the bracket. I want it outside the bracket. To move it outside of the bracket, remember you have to multiply it by this. So it's -2 times -4, so it's actually +8. Well, this has become quite multicolored. So where are we? We have y equals -2 x squared minus 4x plus 4 plus 18. So the only thing I have left to do is to factor that trinomial. And again, it's a perfect square trinomial because the number that multiplies to 4 and adds to -4 was the number over here in my brain bubble. So I get x minus 2 squared plus 18. Oops, 8 plus 10 is 18. And look, I have the exact same equation that I got already, but certainly this one took me longer. So I hope that helps with this question. If you have questions, post them in comments. Come see anybody in the math department, and good luck on studying. Bye-bye.